Hi everyone, welcome to MathSux. This video is going to help you pass the Algebra 2 Common Core Regents. So here is part 2 for January 2023's test. Question 25. Algebraically determine the zeros of the function below. So I'm going to start doing factor by grouping. So we're going to split the equation into two parts and then take the GCF of each little group. So this first group here, we could see that the GCF is going to be 3x squared, leaving us with x plus 4 inside. And over here in this group, we can see the GCF is going to be 3, and we're left with x plus 4, also inside. So the magic of factor by grouping is that we're going to take the outside numbers and combine them. So 3x squared minus 3 is one group. And then the two binomials that match are just going to go over here. So we're not done yet. We need to find the zeros, right? So we can actually find the GCF of, we could take out a 3 over here. And then just leave the x plus 4 the same. And we can factor this one more time. This x squared minus 1, we can do difference of two squares. So if we do 3 times x plus 1 times x minus 1, and then just bringing down this x plus 4, and then setting it equal to 0, now we can find our zeros. So we can see that x is going to be equal to -1, 1, and -4. And that's our answer for question 25. Question 26. Given a is greater than 0, solve the equation a raised to the x plus 1 equal to the cubed root of a squared for x algebraically. So here we can, because these are both raised to the, these both have the same base, we could set them equal to the exponents equal to each other. But before we do that, this isn't an exponent form, right? We have to switch this. So this cubed root of a squared is really equal to a raised to the 2/3. So these are equal to each other. And now since they're the same base, we can set x plus 1, the exponents, equal to each other 2/3. Subtract 1 from both sides, and we get x is equal to -1/3. Question 27. Given p of a is equal to 1/3 and p of b is 5/12, where a and b are independent events, determine what the probability of a and b is. So the key thing here is that we are dealing with independent events. So the formula for p of a and b for independent events is just going to be p of a times p of b. So that's super simple. We just need to plug in 1/3 times 5/12. And we get 5/36. Question 28. The scores on a collegiate mathematics readiness assessment are approximately normally distributed with a mean of 680, a standard deviation of 120. Determine the percentage of scores between 690 and 900. So our lower will be 690 and the upper will be 900 to the nearest percent. So this is a calculator question. So let's go get our calculator out. And what we're going to do is go second bars for distribution, then go down to normal distribution, choice 2, and then we're just going to plug everything in. So I happen to have it in here already. So lower is 690, upper is 900. That's the range we want to find out the probability in, which looks something like this. And now we just need to press enter. And we get this number 0.4334, and then we want it as a percentage. So we're just going to multiply times 100, and we get 43%. Question 29. Similar kind of question. State an exponential regression equation to model these data, rounding all values to the nearest thousandth. So it's the same idea. We're going to be using a lot of the calculator to answer this question. So we're going to go to Stat, edit and enter in these values here. So I have them entered in already. We have 1, 2, 3, 4, 5, 6 for L1 or X, and then L2 is 3.9, 6, 11, 18.1, 28, and 40.3. Okay, so we're good. We have all our numbers in. So now we're going to go to Stat, go over to Calc, and then we're going to scroll all the way down, or you could just press 0, to Exponential Regression. Press Enter, enter, keep entering, and then we get our values here. So we have y equals, our A is 2.459. It says to round to the nearest thousandths, 10th, 100,000, so we want 3 numbers after the decimal. And then our B is 1.61, rounding up 6. 615 is next to the 9, so it becomes a 6 raised to the x. And this is our answer. Question 30. Write the expression a of x times b of x minus 3c of x as a polynomial in standard form. So let's take a of x, multiply it by b of x, and then minus 3 times c of x, which is x to the 4th minus 5x. So let's focus on what's going on in here first in the parentheses. So we're just distributing x cubed times x squared to get x to the 5th plus x cubed times 7. And then we're going to do the same thing distributing the 2. And then last but not least, we got to distribute this 1 also. So we have all of this minus, and then we're going to distribute the 3. Minus, and it's a minus 3 also, so be careful there. So minus 3x to the 4th, and then we have minus 3 times minus 5x, which will give us plus 15x. So now we need to combine like terms. So notice this is the only going in order, so this is the highest degree we have, x to the 5th. Here we have only one x to the 4th, so minus 3x to the 4th. We have 2 cubes, x cubed, so we're just going to add those together to get 9x cubed. 1x squared. (14x plus 15x) will give us plus 29x, and then we're left with this minus 7. So we get this whole answer, x to the 5th minus 3x to the 4th plus 9x cubed minus x squared plus 29x minus 7 as our answer. Question 31. Over the set of integers, completely factor x to the 4th minus 5x squared plus 4. So here we can use product sum to get net minus 4 minus 1. And because this is to the 4th root, we're going to just do x squared minus 4 and x squared minus 1. And notice both of these can be factored even more using the difference of 2 squares, where we have x plus 2 times x minus 2. And then for x squared minus 1, we have x plus 1 times x minus 1. And we just needed to factor, we don't need to find the zero, so we can just leave the answer like this. Question 32. Natalia's teacher has given her the following information about angle theta. So theta is between pi and 2 pi, and cosine of theta is equal to radical 3 over 4. Explain how Natalia can determine if the value of tan of theta is positive or negative. So I'm just going to draw a little unit circle reference where each of these represents where trig functions are positive. So this is all the trig functions are positive, this is sine is only positive, tan is only positive, and cosine is only positive. This is really 180 degrees and 360 degrees. So we know that angle theta must be in here or here based on this. Because here we have one 80 to 360. And this next part, cosine of theta, is radical 3 over 4, but notice that it is positive. So it's positive, so all the quadrants where cosine is positive is here and here. So the only two that overlap is quadrant 4. So we know the angle theta is going to be in here somewhere, which means that tan is going to be negative. So we can write that in our own little words here. So we Question 33. Solve the equation radical 49 minus 10x plus 5 equals 2x algebraically. So the first thing I'm going to do is get the radical alone, because we're going to need to square the radical. So just subtract 5 from both sides. And now that the radical is alone, we can square both sides of the equation. So we can drop the radical, but now we need to expand this because now we're squaring it. And we want to now just solve this like a normal quadratic equation. So we're going to bring everything to one side. And to solve this, I'm going to use the quadratic formula. So the first step to solving this is I'm going to calculate everything that's under the radical first. So we're going to get two possible answers. We'll have 10 plus 22 over 8, and we'll have 10 minus 22 over 8. So this first one will give us 4. And the one down here will give us minus 1.5. So before we just circle our answers, let's make sure to check our answers. So we want to plug in 4 for x into our original equation and see if it works. So this left side all equals 8, and then over here this also equals 8. So 4 is definitely one of our answers. Good. And now let's check our other value for x that we got, minus 1.5. So just plugging in 1.5, negative 1.5 into that original equation. So this left side equals 13, and now let's check out the other side. It doesn't look like it's, this other side equals, the right side equals negative 3, so this does not work out. So we're going to reject this and just say that x is equal to 4. Question 34. Joette is playing a carnival game. To win a prize, one has to correctly guess which of 5 equally sized regions a spinner will land on, as shown in the diagram below. So you can see they're all equally placed here, and it tells us that, 2 equally sized regions. She complains that the game is unfair because her favorite number 2 has only been spun once and 10 times she played the game. State the proportion of 2s that were spun. So we want to know what actually happened when spinning this, and they told us that it was 1 in 10 times that 2 was. So in the experimental probability, she experienced that 2 was spun 1 out of 10 times. Now it's asking us to state the theoretical probability of spinning a 2. So theoretically, the probability of 2 when we look at this wheel should be 1 out of 5. Because there's 5 total different things the spinner can spin on, and only 1 2, and they're all equally likely. So the answer here is 1/5. This question continues on. The simulation output below shows the results of simulating 10 spins of a fair spinner repeated 100 times. So there's 100 little dots. Does the output indicate that the carnival game was unfair? Explain your answer. When you look at this, it looks like our mean. We could see that 0.1, 1/10, which is what we experienced when we did it experimentally, falls within 2 standard deviations of the mean. So the data is accurate if it falls within that 95% range of the mean. So to write this up, we're just gonna have a quick little sentence. And we know it occurs 21% of the time. If we count up all these little dots, this adds up to being 21, and it's out of 100. So we know that 0.1% occurs 21% of the time, which is not unusual and falls within 95% of 0.2. And that 0.2, remember, is the theoretical probability that we're kind of using as our mean. Question 35. Graph c of x, and when it's equal to -9 times 3 raised to the x minus 4 plus 2. So I'm going to plug this in the calculator. So we could see the shape that it's going to make, and it looks like this line goes along too. And when we look at the table, we can just get down some coordinates that we see. So we have 2, 1, 3, -1, 4, -7. And if we scroll to these negative x values, you can see that everything is heading towards 2. Looks like it's always approaching 2. So here we can just do a little sketch and then label this c of x. Okay, so now it's asking us to describe the end behavior of c of x as x approaches positive infinity. So if x is approaching positive infinity going this way, what is y doing? So y, c of x, is approaching negative infinity because it's getting all these negative values down this way. And the next part of this says describe the end behavior of c of x as x approaches negative infinity. So as x approaches these negative values, what is y doing? And we could see that it's approaching 2. And you could see that on your calculator also. Question 36. The monthly high temperature degrees Fahrenheit in Buffalo, New York can be modeled by this function here, where m is the number of the month and January equals 1. Find the average rate of change in the monthly high temperature between June and October to the nearest 100th. So we're dealing with June and October. We know we're going to be working with x equals 6 and x equals 10 based on what they told us about the month. And we're finding the average rate of change, otherwise known as the slope, right? The change in y over the change in x. So this is just going to be equal to b of 10 minus b of 6, October minus June, all over 10 minus 6, the change of y over the change in x. So we could just plug this into the calculator. I'm going to put it in y equals. And just be careful here, make sure you're in radian mode when you're working with a trig function, when you're in the y equals section. So we have 24.9 and then sine of 0.5x. So we can scroll down and see what b of 10 is equal to, which is 59.992 minus b of 6. we get negative 3.878. And if you look back, we went into the nearest hundredth. So this is going to be negative 3.10th and then hundredth. And that's our answer for this part. And now we need to explain what this value represents in the given context. So what this is the monthly high temperature in Buffalo decreases on an average about 4 degrees Fahrenheit from June to October every month. Question 37, our last question. Objects cool at different rates based on the formula below. And we have this formula, and then we have the breakdown of what everything means. Mark makes t-shirts using a hot press to transfer designs to the shirts. He removes a shirt from a press that heats the shirt to 400 degrees Fahrenheit. So if we look at our parts of the formula, can we fill in 400 degrees anywhere? Initial temperature, room temperature, rate of cooling of the object, time in minutes that the object cools to a temperature T. So this looks like it's the initial temperature. So I'm just going to fill that in. The rate of cooling for the shirt is 0.0735. So the rate of cooling, R, is equal to 0.0735. And the room temperature is 75 degrees Fahrenheit. It's room temperature, 75 degrees. Using the information, write an equation for the temperature of the shirt, T, after T minutes. So we're going to be having T, leaving T as T. Okay, so now let's fill in the equations. We have T is equal to T sub 0, the initial temperature, 400 degrees, minus the room temperature, 75, times E to the negative R, 0.0735, T, we're leaving that the same, and then plus T sub R, which is the room temperature again, 75. So that's the answer to this part of the question. Now let's look at the next part. Use the equation to find the temperature of the shirt to the nearest degree after 5 minutes. So now we're going to use this plugging in 5 for T. So we're just going to, and then we could just plug that into our calculator. Plugging in for T, 5 was 75. So the only thing we changed here from this formula, we're just bringing down this formula and putting in 5 for T. And now we could just calculate this using our calculator. So I'm going to start with the exponent, negative 0.0735 times 5. So this is going to be E raised to this number, negative point, and then times 400 minus 75, and then plus 75. And we get 300. So we get more numbers after the decimal point here, but they wanted it to the nearest degree, so we're just going to leave it as 300. So far so good. Now there's 2 more questions based on the same information. So here we have, at the same time, Mark's friend Janine removes a hoodie from a press that heats the hoodie to 450 degrees. So now it's giving us different information, where the initial value, T sub 0, is going to be 450 degrees. After 8 minutes, so we see after 8 minutes, we know T is going to be equal to 8. The hoodie measured 270 degrees, so that means big T on the outside of the equal sign is 270 degrees. The room temperature is still 75 degrees, so T sub R is going to be the same as it was. Determine the rate of cooling, so find R to the nearest 10,000. So I'm just going to separate these 2 pieces of paper so we can kind of rewrite our formula here. So this time we're going to be finding R, and we know what big T is 270 degrees, and it's equal to the new initial value, which is 450, minus the room temperature, 75, that's the same, times E to the negative R, we don't know what R is yet, that's what we need to find, times T which is 8, they told us 8 minutes, plus the room temperature again, 75. And then we're going to need to just solve this algebraically, one step at a time. So let's first bring 75 to the other side. You can divide out this 375. And we get 0.52, and we're left with e to the negative 8r. So to get rid of this, to solve the rest of this question, we're going to be using ln. So ln of 0.52 is equal to negative 8r, because ln has that base of e. So e to the negative 8r is equal to 0.52. We almost have r alone. We're just going to divide both sides by negative 8. So if we have ln of 0.52 divided by negative 8, we get 0.0817. So r is equal to 0.0817. And now this last part, the t-shirt and hoodie were removed at the same time. Determine when the temperature will be the same to the nearest minute. So now we're just going to take our equation from the first part and this part and set them equal to each other, and then solve for t. So the equation from the first part is right here, and we're going to set it equal to this other equation that we got here. So we're going to do the same thing, 450 minus 75 times e, and then now we know the rate is going to be negative 0.0817. T, we want to know to the nearest minute, which is represented by t, and then plus 75. So you can see that these 75s are going to cancel out. And then just to simplify this more, I'm just going to subtract the numbers in the parentheses on both sides. So we get 325 e to the negative 0.0735 t is equal to 375 e times the negative 0.0817 to the t. So to make our lives easier, because it doesn't say how to solve this, it doesn't say to solve algebraically, we can just plug this into our calculator in the y equals section. So we have 375 e to the negative 0.0817x, and we have 325 e to the negative 0.0735x. Okay, so if we go to graph, we'll get this nice picture here. And if you go to second calc and then intersect, we're going to get this value of x is equal to 17. I mean, they want it to the nearest minute, so we're just going to leave it to 17. And that's our answer. So I hope this review is helpful for you, and if you have any questions, please let me know in the comments below. Good luck and happy calculating. So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!